Well, we've got collisions here between a little car and a truck. So this is the before, and this is the after. Now when I see collisions, the first thing I think of is momentum. I might be using it, I might not be using it, but it's the first thing I think of when I saw that picture without even reading anything. But this is about momentum. So 2 kg toy car, which we've got written here, is used to study collision. As shown below, the toy car is originally travelling at 0.5 to the left, which is written down there as well, and it collides with a 5 kg truck in the opposite direction. 5 kg, there's the truck going other way. It's at an unknown speed. There we go, unknown. After the collision, both the toy car and the toy truck are not moving and are stuck together. So what's the total momentum of the truck and the car after the collision? Well, P equals mv, so we've got to add them both up. So we've got mv plus mv, mass of 2 times velocity afterwards 0 plus mass of 5 times velocity afterwards 0. 2 times 0 is 0, 5 times 0 is 0 is 0. 0 momentum, no momentum after the collision. What's the total momentum of the truck and the car before the collision? We can't work it out because we don't have the initial speed of the truck. But what we do know is that the total momentum before and after is the same. So after it was 0, so before it also must be 0. And I'll give you a clue there, 1 mark. Usually they're pretty easy questions when they're 1 mark. Calculate the speed of the truck before the collision. This is the hard one for 3 marks. So now we've got to calculate that speed. We're going to use the momentum. So we know the momentum before the collision equals 0, and that's made up of the momentum of the car plus the momentum of the truck. So 0 equals mass of the car times speed of the car, 2 times 0.5 plus, what's the mass of the truck? Mass of the truck is 5 times the velocity of the truck. We don't know what that is. 0 equals 2 times 0.5 is 1 plus 5 times velocity. Rearrange that, we get negative 1 equals 5 velocity. Divide both sides by 5, we get negative 1 divided by 5 equals velocity, which is negative 0.2. Why is it negative? Meters per second. It's negative because this one's going is positive and it's going that way, so that's the positive direction. This one's going the other way, so that's the negative direction. And it's 0.2 in that direction. So we can write that down, 0.2. And maybe we'll just put to the left. That's what the negative means. Alright, next question. Here's my picture again. And is this example a collision example of an elastic collision or an inelastic collision? Support your answer with a calculation. These definitions, or these words, come from the definition of if kinetic energy, total kinetic energy, total, is the same before and after, it is elastic. Elastic. Okay? If it's not the same, it's inelastic. So let's just do that before and after. Before, so kinetic energy equals half mv squared of that one plus a half mv squared of the other one, which equals a half times 2 times 0.5 squared plus a half times 5 times 0.2 squared, which gives me 0.25 plus 0.1 joules, which equals 0.35 joules. That was before. Now what about after? After, we have kinetic energy equals half mv squared plus half mv squared. So half times 2 times afterwards, the speed is 0 and 0. Hopefully you can look ahead and see what this is going to equal straight away. Plus a half times 5 times 0 squared. That's 0 equals 0. Before it's 0.35, afterwards it's 0 joules. Not the same. So it's inelastic.